All right, and we are live. Let's see who's joining today. All right, we've already got some viewers. Welcome to today's Let's Profile episode. How's everybody doing? All right. So. All right, so I'm just gonna get started today. So let's share this entire screen. Just make sure that's thinking. All right, so. All right, so today we're going to be taking a second look at Parca Flamegraphs. And what we're going to do today is basically the thing that we ignored last time, which is one of the very expensive things to do in the Flamegraph building are these memo tables. And basically these occur every time we want to add something to the Flamegraph. So let's say, and again, this is going to be a bit of a meta episode because we're looking at the Flamegraph while trying to improve the Flamegraph implementation. And this stack basically happens every time we're inserting a function name. And the reality is that this can happen quite a lot in repeated ways. And whenever we try to add a string, what Arrow does is it basically looks up, do we know this string? Is it already part of our dictionary? And if it's not, well, then we add it, and then we just add the index into the dictionary into our Flamegraph. We never really set strings directly. The dictionary is there to deduplicate strings, basically. And so we need to do this every time. Hello, Matthias. Welcome to the stream. And the way that we're going to try to optimize this away, and this is actually kind of a first for Let's Profile, because I did have a previous attempt at trying to implement this, but I kind of set it aside because I was just trying to understand whether this was going to be possible at all or not, kind of playing around with the Arrow libraries. And what we're going to do is basically every time we want to add a set of records, a set of rows, we're only going to take the existing dictionary, the new dictionary, see which values of this dictionary already exist, and which are new. We build a new dictionary, and we get a translation table that we can then use every time we add a string. We can just look up, okay, what is the translation number? And we don't need to do these very expensive memo table lookups every time that we're trying to insert a string. So that's basically the idea for today's episode. So I guess let's, before we jump into writing code, let's kind of have a quick look at the code that I tried to already implement for this. So I needed to convert things to a byte array, which probably we're going to want to do today as well. And this is because the record that we get has a dictionary that is bytes, but we previously had the Flamegraph build strings. And so we need to make sure that those types align so that we can unify these dictionaries. If they were of different types, of course, that's not really possible to do. So, and then the difference is we're not going to actually be doing the classic builder, as in we're not going to have the classic string dictionary builder. We're going to have, and that's something that we could see here. That's what we previously did. What we're going to replace it with is just a builder that tells us the indices. Because remember, what we're going to do every time we add a new set of rows, we're going to build this translation table and then only insert these indices. And the way that all of this works is using this array.dictionaryUnifier API. We're not going to go too deep into this, but basically this returns this unified dictionary, and then this is the unifier. So here we're just creating it, and then this unify and transpose gives us a buffer. This is the very, very low level primitive in Apache Arrow, at least in the Go library. I'm not sure if the naming is the same everywhere. And then we can create a transpose indices. Okay, so this is the translation table basically, and then all we do here is what do we do here? Compare the mapping file. I probably prematurely changed the type here. We'll probably skip this for now. Yeah, of course. And then we're going to need to pass these transposed mapping IDs onwards. Okay, so and then at the very end, we're going to need to build them. We're going to build the actual error record using all the individual pieces now. So we can't just use a regular record builder. So I think that pretty much describes the strategy for today. The good news is Matthias, who actually is also in the comments right now, actually already did a pretty massive refactoring, which I hope is going to make this implementation quite a bit easier. So let's dive into it, and let me know if the background music is not loud enough or too loud, or the font is too big or too small. Otherwise, I'm just going to leave it the way it is. All right, so we saw the first thing that we're going to need to change is that we have this unifier that we keep around throughout the whole time of building this Flamegraph. So let's start with that. We have this Flamegraph builder, and there's a new function somewhere. New Flamegraph builder, here we go. Okay, that's quite a big function. So we've got our schema, that's cool. So this is exactly the thing that I was saying. This is no longer going to be possible for us to do. But that's okay, because what we can do is we can just instantiate these builders over here rather than through the schema. And at the same time, what we're going to do is create this unifier and set it. So just returns this doesn't return an error yet, so we're going to need to introduce that. That's all right. Create dictionary unifier. And we're going to need to create mapping with ID dictionary unifier. And we wrap the error. I think we have some sort of finish. Yeah, here we go. So here is where we're going to be actually creating the schema. Just the way this is going to work from here onwards. It's going to be array.new record schema. Right, press, folded line, start line, function name, that's right, system name, that's right, file name. Yep. Children, yep. Cumulative, yep. Diff, yep. All right. Here we go. Thanks, GitHub Copilot. That was significantly easier than typing this out. Did we get all of that right? We need number of rows still. Do we have that? I think we have that. We can use this. I think this is an int64, if I'm not mistaken. Hopefully both return the same type. Cumulative length returns an integer. Okay, so this is int64. Hello, Nicholas. Welcome back to the stream. Hope you're having a wonderful Friday. Let me know if there's anything I can go back about. Catch you up. All right, so in 64, let's see. Okay, I think we're good now. All right, cool. So now we need to do kind of exactly the opposite thing. Children. This is a, okay, I get it. It's That's right, Nicholas. So the question was, from what I saw, today's session is about improving Flamegraph API again, right? That's exactly right. So basically today, what we're doing differently compared to last time is, if you recall, last time we went kind of the easy way by kind of just going with something where we understood quite straightforward how to solve the problem. And there was one thing that I kind of glanced over, which is I said there's going to be a possibility to improve the way that we deal with dictionaries. And more specifically, and we can see this in today's profiling data, what's really expensive, let me make this a bit bigger. One of the things that are really expensive about building these flame graphs are whenever we get a new record to insert into the flame graph, we get multiple records, right? Let's say 65,000 records. I think that's the batch that we typically use. And when we insert that into the flame graph, we go line by line. So every time we insert a new function name, for example, we look up in our builder, do we already know this function name? And that's all of these stacks that we're seeing here. Do I already know it? And if we don't know it, we insert it. And if we know it, we don't insert it and just use the lookup value that we found. And the problem with that is these lookups, even though, generally speaking, they're quite cheap, they are actually very unnecessary when both things are operating on dictionaries. So the improvement that we're trying to implement today is, instead of doing a dictionary lookup to find the function name and then insert it into the dictionary again, we're just going to take the two dictionaries, combine them, we get a translation table out of that, and then use that translation table to directly insert these integers. And therefore, we only need to ever look up a string once to build this translation table. And conveniently, what we've already found is that Arrow actually has some functionality in order to build this translation table. And so, yeah, that's hopefully how we're going to be dramatically improving this. But we'll see, right? As always, we don't know for sure whether this is actually going to yield a big improvement. Different to many of our previous episodes, I did actually do a very, very tiny proof of concept a couple of weeks ago. That had actually nothing to do with Let's Profile. It was just something that I wanted to understand whether it is possible at all. So I played around with this dictionary unifier a bit to see, does this approach work at all? Does it do the thing that we want to do at all? And so that's kind of a little bit of research, let's call it that I've done, but I have no idea whether the performance improvement is actually going to be a performance improvement. So, and for those who have maybe been watching since the beginning, I actually didn't build a benchmark today because we've actually already built our benchmark last time. So we're just going to be able to view the before and after once we've implemented our change. So now, okay, so that's why we want to call the value builder on this. That's why. So we can't use our regular builder. So what we're going to need to do is, what is this? The Arrow API for this? Actually, Arrow. Make sure we view the latest. List array, yes. So we want to do a list builder, exactly. and it's u in 32s. Don't actually need to hold the schema anymore. So that's one less thing. We're not going to hold the record builder anymore because that doesn't exist at all. All right. Go back to this. So mapping start. This is a UN64 builder. So, array dot yep, exactly right. Yep, also right. Yep, and I'm just gonna start with implementing a single one of these dictionary translations, just to keep things a little bit simpler. Did Copilot do the right thing here? I'm not sure. That's how the API works. Does not look like it. Oh, come on. I want to go to the very bottom. That's not working. Binary dictionary builder. Let's run this. New binary dictionary builder. What is going on? Binary. Oh, is it just like new dictionary or something like that? Yeah, here we go. New dictionary builder. That's the one we want, and it just takes the type. New dictionary builder. Like this. And just so we keep things the same way that we had before, I'm only going to change the mapping build ID. Or actually, maybe I'm not even changing the build ID one. Let's see if we can see in the profiling data which one. Hard to say. It's hard to say which one it is. So I'm just going to start with the build ID, and then we're going to work our way backwards. So let's look at our proof of concept again. What we did was we just kept build ID indices. So you want a just like a here it is, new in 32 builder. That's all we're gonna do, and the rest we're just gonna complete exactly the way it was before. Boolean64, that's right. Hold it as a Boolean. Location line is a int64, did that right as well. Start line is an int64. Builder, wait, builder is wrong. No, these are all wrong. It's array. Array, oops. Not opt. This is the function name. So here we're going to do the dictionary again. Yep, exactly the same. Here we're going to do string, file name. Again, the same thing. All right. Labels. Again, we're going to do just a string. Builder children, we already have. Builder cumulative, this is an int64 again. And diff int64 as well. Okay, all right. And our editor is happier now as well. Here we're gonna attend to the indices. Right. Cool. Now we actually need to keep our unifier. I'm gonna keep that here. Builder mapping. I'll keep it same. It's kind of long name, but we'll survive. Right, and what type is this unifier thing? It is of type dictionary unifier. And that's an array. All right. Cool. So we have all of our building blocks, I think. Now we need to actually modify some things. So here, how do we get? Did we ever get to this part in the proof of concept? I wonder. That's not it. Okay, so here we go. So we did do this. So basically, the way this works is we take our indices, we build the array of the indices, we get the final dictionary from the unifier. And one really cool thing about this unifier is actually, I think it said in the docs, get result returns the dictionary type choosing the smallest index type that can represent all the values. So basically, dictionaries have indices, right? Like it's a table, right? It's a lookup table. So 0 has a value, 1 has a value, 2 has a value, and so on. And it actually makes sure that the produced dictionary at the end uses the smallest type of integer for this mapping to be able to kind of keep the size of the dictionary as small as possible as well, which is a really nice side effect of doing all of this, because typically what we see is we actually don't have too many entries in these dictionaries, but the values repeat over and over and over and over and over again. And so this is a very, very nice functionality to have. Now this API changed slightly. We're only returning the record and an error. So that's super nice. That makes all of this quite a bit cleaner as well. And now we're actually creating the array as a dictionary. We don't need this anymore. So now we can replace this here. And now the actual thing where the translation happens, we're going to need to insert. So the way this thing works is, okay, we need to make sure that the error is handled. Do we not do any error handling here? Just be a nice citizen. I don't like that. We want to basically create stack trace, create Flamegraph builder. Yep, that is the way I like it. Now, the way this works is we basically get multiple batches of Apache Arrow records into this, and then we can use these to incrementally build the Flamegraph. The reason why we implemented it this way is right now that's not the case yet, but we'll be able to build the Flamegraph in a streaming way, right? Like every time we have some data ready coming from the database being symbolized, we can already start building the Flamegraph. Whereas right now, we load the data from the database, we symbolize it, and then we build the Flamegraph. But because we've basically already built it to be like iterator based, this is going to be very easy to transform so that we don't need to do it in that way. So that we can ultimately have it in a streaming way, hopefully making all of this even faster. It's pretty hot in Berlin, I have to say, so I'm gonna need to hydrate. All right, so what do we do next? The first thing that we're going to need to do is we're going to need to build our translation. And this is something that we already kind of did in the proof of concept. So I'm going to take this. This field compares the current sample we already had. Oh, that's right. All right. Yeah. And I insert. So we have our dictionary unifier, that's still correct. Our R, let's make sure that this is still correct. The record reader has mapping build ID dictionary. Yep, it does. That's good. All right. This error is still right. Okay, let's make sure we get some error handling here. Unify and transpose. Yep, exactly. Yep. I'm getting the feeling that it's probably eventually going to make sense to build some sort of abstraction around this. We already have, seven occurrences of this, and yeah, this was kind of a weird one when I played around with the proof of concept. This is just one of the worst APIs I've ever seen. For what it's worth, it is a very, very, very low-level API. So granted, I don't think it has to be pretty, but it definitely took a little bit to figure out how to do this correctly. Now, let's see. that looks good. That looks good. Now we actually need to. We had it in the add row thing, yeah. So do we still have something like this? Add row values. Add row values. Maybe it's append row. Yeah. Okay, that's the one. So what does this take? It takes a record reader. That's our current thing. That makes sense then. And we can just transpose mapping ID indices. And that is an array of int32. Now, last but not least, we actually need to insert this over here. So builder mapping ID. No, this is not right. This should be like indices. 32 builder. Yeah, this one is not right. Now, let's go back to this. Now, this is going to need to look quite a bit different, but let's just. So we still need to check whether it's valid. And then the next thing we just check is, what did we do? Sorry, my brain is not at its fullest today. Append row. Passing the transpose mapping IDs. So the null cases we've already done. Now, what is this diff? We removed that, and we, of course. So what this is the translation table, right? So what we're doing is we're looking at what was the previous index in our dictionary and what is the new index in the transposed or translation table, right? So we just do that lookup and immediately add it. There's no dictionary lookups that we need to do anymore at this point. That was kind of the whole idea of what we're doing here, right? So that's super, super cool. And it means that this becomes way simpler. There we go, we can delete that. And we don't even need this anymore because that's something that the dictionary translation table has already taken care of for us. Now, I'm pretty sure this is not going to compile yet, so I just want to see where we left things off. Let's see, arrow 227. All right, of course, we need to actually pass the transposed. I'm actually, because I know that we're going to be doing this all over the place, I think I might actually already start writing a teeny tiny abstraction here. I don't know if an abstraction is even the right word. I'm just going to add transpose. What do they call it? Mapping and unify and transpose. Transpose table, transpose, Transpositions. Someone who can English better than me, let me know if transpositions makes any sense. So we're going to start out with mapping IP transpositions. And this is an array 32. And we're going to have a function on the Flamegraph builder that new transpositions. Oh, the Copilot is going wild with this one. Let's not do anything here yet, and we're just gonna take this. And we want to add a we want to also keep transposed mapping IP. These data, that's like array.data or something like that, and then that's already the thing that we already have. All right, the reason why we're doing all of this is in Arrow, Arrow has this concept of allocators, which allows us to more intelligently and a little bit more manually manage memory. It actually doesn't cause like the garbage collector to go wild or something like that. You can only make things better with these unless you implement custom allocators. But it's basically just to make sure that memory is managed in an efficient way, and in the way that Arrow wants it to be, because part of the Arrow API is that the data is very specifically laid out in memory, and that's actually the API. So you can pass an Arrow record from one language to another, and they will be able to understand this layout. And that's why it's really important that Arrow tightly controls the memory layout. All right, so we've got this, Yeah. I don't think, let's see how this goes. Okay. Of course, we're going to need the profile.record reader and probably something else. Let's see, 286, 289, too many return values, and 299 transposed mapping indices declared and not used. Okay, so we actually need to make use of this stuff. So this needs to return an error as well. Yeah. Mixed, named and unnamed. There. It's a type. Transpositions is a type. Okay, that was just syntax. Why it gave us a bad error. Okay, and now finally, positions transposed mapping ID indices data. Yep, and mapping ID transpositions is the indices. Yep. All right. Because now all we can do is, actually I am gonna return a pointer to this. All we're gonna do is here is have our transpositions. Yep. All right. It's on the Flamegraph builder, so I need to do FB new transpositions. Now we can start to go through all the errors. Okay, yeah, we're not using this yet. 216. Just going to be passing T. 2.4. Pass T. Because anything that's an arrow. Okay, so we can do T. Transpositions. And then where we're using this thing will be P.mapping ID transpositions. All right, that's getting better. 293. Let's see. Here now we want to no. Here we want to printer 306. Oh, feature here. Cannot use transpose data. Oh, okay. This is right type. Four 9. Not cool. Oh gosh. Actually, this is going to be easier to rename this instead. Right, much better already. Very different errors. 500. Cannot use dictionary builder. Aha, we need to do a type assertion. Cannot use arrow binary string type binary data type as arrow dictionary type. This is okay. This is like something like this. Arrow dictionary type. And has index type and value type. Index. Something and value type. This is arrow primitive types. Let's do view in 64. I don't know. We're gonna optimize this anyway, so just do something for now. Here. already taking care of that, so it doesn't actually need to be an opt builder anywhere. Don't need to do this because, or do we need to do this? No. Builder not found. It's like okay, fine. Let's give that one enough. Oh, I realize now what the problem is. It's none of this. It's okay. So 508 again. Now we need to do this again. A little silly of an API, I have to say, but it is what it is. Okay. Oh, what's wrong with this one? Again, this thing. Okay. We're good with these. All right, we're back. 3, 6, 4. And what's going on here? Exclusive add undefined. Were we not using an int64 builder before? Let's look at main for a second. I just want to see the Flamegraph builder and the cumulative. This actually does use builder opt. I think this might be an API that maybe we defined as polar signals somewhere. Yeah. Let's have a quick look at this. PQ arrow. Builder. Okay, so we're okay. All right, we are going to need to use that kind of builder for this then. So if I remember correctly, the reason why we need this is so the cumulative value keeps getting updated as we insert new frames, because the same stack trace can occur multiple times. And so we need to add it up so that the final value is correct. However, the arrow APIs unfortunately don't allow doing this. So Easy enough to do though, once we find the right thing. So cumulative is actually going to be builder, and it's an opt in 64 builder. Yeah, and the same thing is going to happen here. Now I have to wonder, there's probably a bunch of stuff that we're gonna need to... that was my bad. What is the Flamegraph builder? All the ones where this is the case, we definitely need this. So, all right. Well, these basically all need to be possible to be modified at runtime. So children is builder. Function start line. Builder. Boolean. Builder. Okay, now how did we instantiate these before? Did a type assertion on that? How did that work? Huh. I am baffled. Why does this work? We create the record builder, and we just do type assertions to this? Why does that work? Because this builder is coming from the builder package. Record builder is coming from the builder package and not, okay. All right, that means we can just go here and there are probably new builder, new opt, boolean. Okay, that makes sense now. So builder, new opt, boolean builder. Builder, new opt in 64 builder. Data type. Well, I guess it has to be. Let's have a quick look at the record builder. But it probably new builder. Where's this function? Oh, builders here, no. List builders here, no. Builds here, yeah, okay. Okay, so we just pass the same types. Okay, not too bad. list builder. Also just list builder. Okay, that might have already done the trick. And now these two opt. It's going to be in64 and opt here as well. Quite a bit more typing today than I anticipated. What's wrong with this one? Wait. What? All right. Okay, looks like we're getting down to only a few errors now. So 541, 541. Okay, don't return an error. 623. Okay, what's wrong with this? Undefined array field. Arrow.field. No, it's arrow.array. Four. Okay, yeah, this is something that we're going to need to take care of now. Let's see. Does the dictionary unifier need to be released as well? Unsurprisingly. All right, then all of these we're going to need to release. Plus, oh, that's it. Right. 675. Fields. Okay. Well, this is kind of complicated anyway. Okay, we're going to need to actually rewrite this whole function. So what this previously did was it iterated over all fields and then added stuff for each field. It's kind of nicely readable, I guess, but it's not going to do anymore now. And I think it's going to also probably be more efficient this way. So we're going to start with if r.mapping is valid, location row. And basically, this is, like I said, every time we're actually inserting a frame into our arrow record. That's what this function does. And this is the resulting arrow record that contains the flame graph at the end. So if it is not valid, we're just gonna take all of these cases. Mapping start, mapping limit, mapping offset. Yeah, I'm quite liking this, if I'm honest. The build ID. Okay, now let's take all of these and let's put them into the valid one. Actually, this reads so much nicer. I'm quite happy that we're doing this. And this is actually gonna go away as well, because exactly the same thing with the dictionary is gonna happen to this. Cool, cool, cool. All right, I love it. So next, oops, we've taken care of all things. File dict. Yeah, okay, now this we've done, build ID we've done, location. Oh. Copy these. We can still improve at a different point in time. For now, we just want to get this to work. All right, so we've done this. And I actually think we've made this quite a bit nicer. Down here. Uh-huh. Ooh. Where is this happening? Flamegraph new record 625 623. Okay, so it's happening in here. That means we have some sort of okay, I see it already here. Mm-hmm. Actually, this is something that I remember from the proof of concept. There was something that it was going to tell us the type. So this type was used some. Here we go. We actually need to move this Actually, why don't we move the schema creation in here then? I think I like that better. That is looking nice. Let's test again. Still something's off. Let's see, what did we do wrong? So, mapping file, what? Ah, we made everything UN64s. Okay, so this is a UN16. Okay, let's do things the way that they were done before then. Don't mess with that. Someone already thought about this. So mapping file UN16. Function name UN32. System name UN16. Function file name UN32. Labels 32. All right. I think we're matching now. Let's see. Oh. Okay, so something is happening. So the code compiles. That's already something, but it looks like we don't actually have any values. That's surprising. Why is that? Oh, this was really strange. Yes, I remember this. We actually had to do this outside. Let's make sure we add a comment. No idea why, but let's first make sure that this is still true. Array is. This is now in the tests. That's good. But yeah, this is exactly where I was. No idea why this is needed. But it's when moving this below, somehow this returns 0. What? I'm guessing that's because we call new array. Okay, that makes actually perfect sense. This has to be here because after calling new array, the builder is reset. Now, arrow test 125. Mapping files, what? We'll copy this and make it require column binary picked. Actually, what we're going to do here is we're going to convert this to a string because the assertion otherwise is going to look super weird. But see if that works. Is it still 125? Oh, what? Ah, that's a different test. 406. Like these. Better now. We've got passing tests. Woo! I know for a fact that these tests are pretty extensive. Whoops. There. So I'm actually very confident that this works. So what we're then going to do is we already wrote a benchmark last time. And we're going to run our benchmark and arrow unifier. Now, our good old trick on the new tests, we just want to run our benchmark. Let's just run it a couple of times, and we set 5 times, and write that to our new one. Let's see. Let's see if this does anything. We definitely want to do this with all the other ones as well. It may be that the build ID didn't make too much of a difference. Oh wow, we can actually see a pretty significant difference already. Wow, I didn't think it would be this big. That's a 15% improvement with one dictionary unified. Wow. Wow. I am actually very impressed with that. That's super cool. All right, very exciting. Now I definitely want to add all the other ones as well. Okay, so we have our transpositions. So we're going to do this for all the dictionaries, basically. So we're going to do a builder mapping file indices, and it's also going to be an array.int32 builder. And this is also going to get a builder mapping file dict unifier. We're going to remove that. Okay, so I don't know why we did that. That was unnecessary. We want builder file fire. And we want to do mapping file indices. Oh, yeah. All right, that's the one. Now the transport. Now this is basically always the same. Transposition. We're just gonna pass a unifier and right. No, that's a that. At least all of these are gonna look exactly the same, so we can definitely have this. It's not, we're not exporting this function or anything, just to not write the same code over and over and over again, since we're going to be doing this 6-7 times. So we're going to get out of this array.data and array.int 32 and an error. That, and here it's oops, no. I'm looking for nothing. And an error, transpose. And we have the Flamegraph builder, and screen was about to turn off. That, and then the dictionary. That is a very long line. All right, so, oops. Okay, it's somebody interface apparently. Unifier. And this is data, this is buffer. And we can just return this, comma, this. Right. All right. Oh, no, we can't. And okay, wow, that was actually a lot of typing. Now let's do the thing we actually wanted to do. No, cool. So let's rename this. Transpose mapping. I just already transposition. So mapping ID indices data. Mapping ID. Mapping ID indices data. Mapping ID indices. Okay. Now we can finally do the thing we actually wanted to do. So mapping file indices mapping. File indices data indices. And row. T dot mapping file indices value r dot. All right, and we can remove this. And that's no 409. Okay. Now we need to check if the file is the same. That's something that we didn't run into with the build IDs. So that's definitely still possible, but look at the line we just changed. And so let's get the index, and that's this of the Flamegraph. What is this? So we just want to check if the indexes are the same. Translated location. Translated. We don't even have to do an expensive byte comparison here. We just compare the to integers. That's actually really nice. Oh, we need to pass transpositions here as well then. All right. 3, 4, 2. Now we need to actually pass the transpositions. Pass the transpositions here as well. More to do, but that's okay. RT 239. Positions 376 equal as the transpositions 200 transpositions 6 mapping file indices. Yeah, okay, so now we need to do the same deal. I guess. We need the type. No, there's no way around it. To basically just copy this. So mapping file indices, mapping file indices, mapping file dictionary. There's a lot of potential to do something wrong here. Let's just search for dict real quick. I'm sorry, build ID. I meant build ID. This doesn't contain build ID anyway. That's good. So then let's fix this. Mapping file. We can't. Okay. Mapping type. Sorry, not mapping. Build ID. File type. Oh, we already said that something was wrong. Yeah. Okay, build ID. Well, oh yeah, that's because here. Coming to an end, 6, 8, 9, 6, 8, 9. 230. File. Typo 831. Right, same test failure. Flamegraph arrow test. 405. Okay. All right, test passing. Now, let's see. We're getting faster. I want to say that already looks a little bit faster. Looks like it didn't make quite as much of a difference, but we got another 3 to 4%. All right, very cool. All right. I think, everything else from here onwards is going to be very, very mechanical, but we've already improved by 20 or so percent. Maybe we can run this one more time and just see the CPU profile. Oh, wow, that's even faster now. Okay, that says 25%, definitely better. All right, but let's have that opened in my other browser window. 1 second. So now, and row. Okay, so there's still some dictionary, and I'm going to guess it's the one with the function names that is still pretty expensive. Okay, I really want to see this improvement, so let's still do it. Of course, at this point, it's definitely pretty mechanical, but I am very excited about this change. So let's do the function name. We do the function name. There's a new feature. There is a new feature. Is this going to work? Okay, this is going to require more thought. There's a new feature that inserts pprof labels as frames. So if you have pprof labels, it will insert them in here in line. And it looks like we just added it to be a regular function. All right, I think we're gonna stop here for today. We can see that this improvement definitely works very, very well. And going to guess, judging by this profiling data, we're gonna get a really massive additional improvement. We can see that at least, here it's 8% is being used, and here it's another 6%. So it's quite possible that we'll get to somewhere in the realm of a 40 to 50% improvement from these dictionary improvements. So that's super exciting. We've already gotten to somewhere between 20 to 25%. So yeah, really cool. All right. With that, I'm going to end today's recording here. I hope you learned something. I hope you enjoyed this episode. As always, like and subscribe. That really helps us see, the popularity of this. So you're really helping us with that. So yeah. Otherwise, have a wonderful rest of your Friday. Have a wonderful weekend, and see you next time at Let's Profile. Thanks for joining, everyone. Bye-bye.